Hey folks, you're listening to the Java Easily podcast, episode number 21.
Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer.
Hi there, welcome back to the Java Easily podcast. Thanks for returning. It's good to have you here. Now, before we get started, if it turns out that you're completely new to Java and you haven't yet grabbed your Java Beginners Starter Kit, just go over to our website at javaeasily.com and go grab it there. It's a super helpful guide to help you get up and running with Java. It's completely free and it'll help you get set up with Java coding today. Okay, let's get back into the show then. So, welcome back to this week's episode. In this episode, we're going to talk about design patterns, or rather, we're going to introduce the idea of what a design pattern is. That's probably a more accurate description to give. We'll actually do a more comprehensive look at design patterns further down the road, but for now, we just want to give a kind of an overview of what a design pattern is and why it's useful. And this continues our mini-series, if you recall, which we're doing, which looks at the different aspects, or the different levels, if you like, that people go through when they're getting to grips with coding with objects in Java. So when you get to design patterns, and you can use design patterns regularly in your day-to-day coding work, you're really flying on all four cylinders then. There's really no stopping you. To all intents and purposes, you're a really awesome programmer who can cut his way through object-oriented code and understand object-oriented code as well, as we'll see, very, very easily. So it's a great skill to have. So where do we start with design patterns? Well, if you remember, we started off this mini-series looking at the syntax. And this syntax, you can do a lot with syntax. It's not just about defining classes, then learning about encapsulation, inheritance, and polymorphism, and then you're done. You can actually do a whole lot more because you can arrange the objects that you create in kind of specific ways which give you better designs for your code. And this might seem abstract when describing this, and this might seem abstract when I'm describing this now, but just stay with me and I'll try and explain. So you can organize objects in different ways together. And when we say organize objects, what we're really talking about is how we structure the relationships between those objects. And how we do that by applying the various syntactical constructs that we've got available to us. So keywords, class, extends, visibility modifiers, public, private, protected, and also the static keyword as well, which we'll come to shortly. So a design pattern really is a way of being able to arrange our objects, that is the relationships between our classes, in a specific way which somehow does something good for the application, or does something good rather for the design of the application. Now, this something good could be different things. It could be to make our object-oriented design more extensible in the future, for example, to allow it to evolve in a specific way, in a specific direction. Or it might be to facilitate code reuse, that is, to make sure that we get reusability of code and we keep things dry. Dry is an acronym that stands for don't repeat yourself. Or it might not be about future concerns of evolution of the code base. It could be about how we create objects, or how we allow the application internally to create objects and that kind of thing. And we'll see an example of that in a second. So it can be those kind of things. Now, these things often seem pretty intangible. That is, they're not immediately apparent. You don't immediately think of them when you're first starting out with objects. But after a while of just coding with the kind of vanilla OO constructs of encapsulation, inheritance, and polymorphism, you start to feel a need for something bigger and something better. You almost want to apply the skills that you've got by understanding those core concepts of encapsulation, inheritance, and polymorphism. You almost want to somehow put those on steroids to be able to do bigger and better things with your code, to make it evolve in a much nicer way, to make the engineering side of the code, in other words, how the code has actually been engineered together, to make that better, and just basically to kind of evolve as developers onto a much higher level of expertise when developing with objects. And that's what design patterns are all about. So let's talk about a specific design pattern, which is probably the easiest one to, or at least one of the first ones that you'll come across, easiest one to visualize and bring to life in your mind, and that's a design pattern called the singleton. So design patterns are often formed in terms of the problem that we have in software engineering that we want to somehow get a solution to. And then the solution then is the actual design pattern itself, or rather the utilization of that design pattern. So let's give a concrete example with the singleton. Let's suppose you want to only ever have one instance of a given type of object in your system. For the sake of argument, imagine it's something really heavyweight that it takes a lot of computational and a lot of processing power to create this object, to instantiate in the first place. And so because of this, number one, you don't want anybody, to be able to create this object or to be able to create alternative copies of this object at will. That's not something you want. Number two, you want to control maybe how this object is created, possibly not, it depends. But moreover, number three, you want to make sure that there's only ever one instance of this object in the application, and whenever a calling client, that is, whenever some code that's wanting to access this object, whenever it makes a call, you want to guarantee that you only ever give that calling code this one and only one specific object, because there's only one that exists in the system, right? So how can we do that? If you think about it with what you already know, you probably start thinking in terms of object construction. You know, how do I actually create an object in general in Java? Well, how you create an object in general in Java is you call the constructor of a class and you invoke that with the new keyword. So person P equals new person, for example. It's the new person part of that expression which causes Java to create a new instance of the person class and to put it on the heap, all thanks to that new keyword. Now, if you think about it, and if you want to restrict people from doing this willy-nilly, as it were, then your first instinct is going to be to kind of do something around that constructor probably. So what can we do with a constructor? How can we make a constructor such that it can't be called by anyone at any time, but can only be called by us, by our class? Well, if we look to the visibility modifiers, we see that we could apply the private visibility keyword to the constructor. Okay. Now, usually, you might have come across this before, because usually we're used to seeing constructors being declared with the public keyword, because we want people to create objects of our classes, right? However, you don't have to declare constructors with public. You can also declare them with weaker visibility. And in the case of our requirements here, where we want to be in control, when I say we, I mean the class we're writing wants to be in control of the creation of itself. We'll come back to this notion of the creation of itself, which sounds a bit abstract as well, I know, so just bear with me for now. But we want to be in control of when and how this object is actually created. And that means that if we mark the constructor for that class, let's say the class is called GraphDB, or Graph Database or something, to represent a massive graph database which is incredibly large, very memory intensive. You know, you only want one of these huge objects in memory at any one time. So yeah, let's just call it Graph Database, or GraphDB, let's call it GraphDB. So in which case what we want to do is we want to make sure that our GraphDB constructor is marked as private. And that means, of course, that the only thing that can create an instance of GraphDB is itself, right? Because by virtue of the fact that we've employed the private keyword, it means that the thing that we apply that private keyword to is private to the class itself. Therefore, the minute you mark the GraphDB constructor as private, removing the public keyword and instead putting private in its place, it means that no other class in the application would be able to see that constructor. In other words, if you try to do new space GRAPH and pressed control and space or whatever it would be to complete that type name, you wouldn't get GraphDB showing up there because it's not visible. That constructor is not visible. It's not visible to anybody, or to any class rather, outside of the GraphDB class itself. Okay? So that's good. That means that now we've kind of protected, if you like, and there's nothing there to do with the protected keyword, but we've protected, if you like, this constructor being called by anybody but ourselves. In other words, by anybody but this particular class. Fantastic. That means that nobody now in our application, no class in our application, can call new GraphDB, which is fantastic. It's just what we want, because we said we don't want people being able to just create loads of these GraphDB objects willy-nilly. We only ever want to have one instance in memory in our application at any one time. This, of course, begs the question then, well, that's kind of cool, but how do you actually then create the object? I mean, if nobody's going to create the object, how do we kind of bring it into being? Is it some kind of like immaculate conception which somehow just appears miraculously? And it's kind of like that, kind of. So let's look now towards the other keywords that we've got at our disposal in our toolbox. This is the entire point of getting a deep knowledge of how the syntax of Java works, because it enables us then to like think through these kind of problems that we might have and to try and think out of this toolbox of syntax that we've got, what might we be able to apply to do the software engineering thing that we want to do? So callers are still going to need to be able to access this GraphDB. Fair enough, we said we don't want anybody to just be able to create it, but we do want them to be able to access it. Otherwise, there's no point really in the class being there, unless it's some kind of like background task we have like ticking away or whatever. But let's assume, for the sake of this example, that other classes will need to get a reference to this GraphDB to be able to, for example, issue queries against it or whatever. The only thing we said before is that they can't physically create an instance of this GraphDB. Okay, fair enough. So in which case, we know we're going to have to offer a public method because other classes are going to use it. It needs to be a public method which allows them to get this instance. So let's call that public method getInstance. Okay? Now, the next question is, because this public method is an instance method, at least how we've described it so far, they wouldn't be able to call it. In other words, in order to call an instance method, you need to have an instance of the class, right? But given the fact that none of the callers would be able to do new GraphDB, they wouldn't be able to call the constructor or invoke the constructor because it's been marked as private. That means, therefore, that it can't be an instance method. Okay, it can't be an instance method. So then once again, we start thinking about the syntax of Java. So what other type of method do we have if we don't have an instance method? Well, after a little bit of thought, we'd come across the idea of the fact that we have class methods. In other words, we have methods that we can invoke against a class instead. And to do this, that's what the static keyword is all about. So if we marked this getInstance method, which we said is public, so that other classes will be able to have visibility to it, if we also mark it as static, then that changes that method from being an instance method against that object to being a static method against that class. So at this point, we've managed to derive a mechanism which means that a calling class can do GraphDB, and when we're saying GraphDB now, we mean with a capital G. In other words, it's the class that we're referring to now. So they'd be able to do GraphDB, which is the class name, dot getInstance, which is the method to get the instance. And we know that's going to work because getInstance now has been marked with static, and it's a class method. Okay, so now we've kind of almost done it, if you think about it. Just by thinking through the syntax that we've got available in our toolbox, we've almost cracked this. We've almost got to where we want to be. We've restricted classes being able to create an instance of the class by marking its constructor as private, okay? But yet we've still given them the ability to be able to retrieve this instance by having a public static method against the class itself. So fantastic, two things. We've protected the instance creation by the fact that the constructor is now private, yet they can still access a reference to this instance, which is going to be the one and only instance in our application, which we'll do in a second, by virtue of the fact that we've now got a method on the class level. So public static method, getInstance. The last part of the jigsaw then is basically to bring this object to life. In other words, to actually instantiate this object. Now, if we think about this, we know, because we've marked the constructor as private, that the only entity that can call new to create an instance on this class, to create an instance of this object, is the class itself. In other words, GraphDB. We also know that inside the implementation of the public static getInstance method, we're actually now inside the class. In other words, we're physically inside the source code file, where we have the ability, finally, to be able to call new GraphDB. Do you see how this is kind of starting to slot together? Hopefully it's becoming clear. I know it's a bit abstract to think of these things without seeing anything, but hopefully it's drawing a picture in your mind of how we're pulling this syntax kind of together to create this software engineering scenario that we're after implementing. So this means in the public static getInstance method, there we can at least create our object. So we could do new GraphDB. Now the next question, of course, is to say, well, okay, well, where do we hold the reference to this? Do we just pass it back out? For example, do we just say that getInstance is a return type of GraphDB, and therefore we'll just do return new GraphDB? Well, yeah, we could do that, but if we do that, we've locked in the aspect that no other class can construct our object directly. In other words, they can't call new GraphDB themselves, but the net effect, of course, is the same because every time they call getInstance, it's going to create a new one of these things and ship it back out. So we don't want to do that, obviously, because then we'd have tons of these objects in accordance with all these other classes calling getInstance to try and get a reference to it. Again, we think back to the syntax toolbox we've got. Okay, so what else can we do? Well, what we can do is we can actually store the reference that we create, and we can store it in the class itself. And if we're storing it in the class itself, what keyword do we think about when we think about the class? We think about the static keyword. So in order for us to store this reference to this GraphDB object that we create inside this getInstance method, in order to store that, we can store it in the GraphDB class itself. This is the class we're talking about now and not the object, okay? And we do that by, as you may have kind of worked out, creating a member inside there, a data member inside there, in other words, a field on the class, which is marked private and static. It's private because, again, we don't want to somehow have other classes being able to reference this instance, because we want to make sure that they always go through this public getInstance method that we've set up, right? That was the entire point of creating that, not creating the machinery around that. So yeah, the data member is private and it's also static. And the reason it's static is because the instance of GraphDB has to live somewhere, and the most sensible place where it can live in order to keep this visibility intact is at the class level, because we don't have an instance to assign it to, and that would be kind of very strange anyway, some kind of like infinite cycle of, you know, an object holding a reference to itself, which holds a reference to itself, which holds a reference to itself, and yada 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 to infinity. That's obviously not going to work. Might even make the machine explode, who knows? But obviously that wouldn't work. So at this point we know we've got a private static data member, so private static GraphDB. We've got to give it a name, let's call it instance, and this means that we've got somewhere we can store that instance when we create it. So what we could do is in the public static getInstance method, we can check that data member, and we could say, do you know what, if it's null, then call new GraphDB, because we've never set up that instance before. And if it's not null, in other words, if we've called new GraphDB and assign it to that reference, and we do that because we've never stored that reference before, and if it's not null, that means we have stored that reference before, in which case we don't have to create a new instance of the object, we can just return that instance that we already created in a previous method invocation of the getInstance method that's been stored there, nice and safe and sound. We can just return that and ship that back to the calling client. So you can see how we've kind of pulled this syntactical machinery together. We had a problem, which was effectively we only want to have one instance of this specific class in our application at any one time. and we still wanted to give calling clients the ability to access that instance, but effectively we wanted to localize and kind of sandbox the creation of that object safely away from any other class in the application, such that we can very tightly control when, and indeed, if we went a bit further, even how that object itself was created. So again, this is what design patterns are about. We have a problem, like the one we just described, and then we have a solution, and that solution, again, what we've just described, of how we arrange the classes together, how we set the relationships up, which data members we have, what visibility we have, what methods we have, how the classes interact, that kind of thing. That's what I'm very loosely terming arrangement. We have this arrangement now, which we've set up with the private constructor, the public static getInstance method, the private static data member for the instance itself, and the fact that the public static getInstance method will, on its first method invocation, physically create the object and store it in that reference. The mechanics of all that, like packaged up together as it were conceptually, this is an example of a design pattern, which in this case is called the singleton design pattern. So yeah, a design pattern takes a problem that you have to do with software engineering. So you're never solving like a business problem. It's a software engineering, a kind of a design problem that you've got. And by thinking through the elements of that problem and looking through the syntax that we've got available to us in a given programming language, in this case in Java, with all the different keywords that we've got and such like, we can come up with this magical arrangement of the kind of participants or the classes or the objects inside which are part of this problem. And that arrangement is what we call a design pattern. And by the way, as well, as a side note, there are different ways of being able to implement singleton, and there are a few issues relating to multi-threading around that particular instance that I've just described. That's too advanced for this particular episode, but what I wanted to do here was just introduce the concept of what a design pattern is. So you can probably appreciate now what a design pattern actually is. Now, the advantage of this, once we've thought through how to make this kind of arrangement of participants, which are in our problem, in our software engineering problem, once we've thought that through, that kind of evolves us, it pushes us onto a higher level as a developer. Because it means that the next time, say 3 or 4 projects down the road or something, or maybe the next project, who knows, or maybe even in the same application, the next time we have this requirement that, you know what, we only ever want to have one of these instances in our application, we can think back to what we did before, and we can say, oh yeah, I remember now, I remember the singleton design pattern, so now I know automatically that in order to make the, let's say, XML ingester class or whatever you've got in your application, again, maybe this is a heavyweight thing or something, in order to make the XML ingester class a singleton, all we've got to do is say, okay, in which case I look at the constructor, okay, I'll make that private, I'll create a public static getInstance method inside XML ingester, that'll basically check this instance variable, which I'll stick in a private static data member on the class, and if that happens to be null in this getInstance method, I'll create one, so I'll call new XML ingester and assign it to that reference, and if it's not null, I'll just return the existing reference back out to the client. Voila, and there you go, bish bash bosh, you've applied this singleton design pattern to another class. And it was easy now, because we'd gone through the mechanics of how we were going to approach that before. Now, the advantage of design patterns is that, you don't have to, every time you've got a really difficult problem, try and, do some kind of mental gymnastics to try and discover how you might be able to mechanistically create this kind of, arrangement of objects. We only did that, and we only described that in this episode, just to get you thinking, get the wheels turning as to the actual kind of forces behind the singleton pattern. I wanted to try and make it such that you kind of discovered how to come up with a design pattern yourself, in this case the singleton pattern, just by thinking through what you already know about. So you already know, for example, about public and private visibility modifiers, you already know about static, probably, and that kind of thing. And also to make you realize then that, even if you get difficult things to do in software engineering, if you just apply a bit of thought to the problem, then you can always derive a solution, you can always get there. You'd be amazed at how much you've actually got in your programming toolbox already that you just don't realize. You just don't realize the full power of the stuff that you know. But yes, I wanted to make you have this kind of like self-realization along the way. But to return to the point, we don't need to constantly go through the mental gymnastics of trying to figure out these kind of mechanisms, because that's what design patterns gives us. Design patterns gives us effectively a catalogue of things like singleton, where they're effectively pre-canned or pre-thought through arrangements of classes. Let's look at it in that kind of way. That you can automatically kind of superimpose onto your own object designs, into your own applications, to solve the problems that they declare they're solving. So a design pattern, as I said before, it normally has a kind of problem definition of the problem it's solving, and then typically you'll have a UML diagram, possibly some sample code as well, which describe, implementation-wise, how that design problem can be solved with that design pattern's proposed arrangement of classes. Now, a lot to take in there, I appreciate that. If you want to dive into this stuff even further and you're really impatient to just get to this kind of level where you can have design patterns literally at your fingertips, then the classic book to read there is a book called Design Patterns, Elements of Reusable Software. It's in C++ though, I think. At least the original version was in C++, unless they've updated it for Java. And that was by a team of 4 very advanced software engineers, pioneers in the field of object-oriented engineering, who are affectionately known together as the Gang of 4, or GOF. So yeah, there's the Design Patterns book by the Gang of Four, you can have a look at that. But we'll no doubt be covering design patterns at some point in the future on this podcast as well, so stay tuned for that. So that about wraps it up for this episode. I hope you found it useful. It's been a bit of a mental stretch, but thanks for staying with me, because as I say, if you understand this stuff, it's only going to stand you in good stead for the future. All that remains to say is have a great day ahead, look forward to seeing you on the next episode, and until then, enjoy your coding journey. Bye.